So, welcome to the beginning of another week. We're about to jump into a unit on quadratics and how to solve quadratics. And a lot of the ways that we use, if you'll remember back from Algebra 1, is factoring the quadratics. But I know that it has been a while, so I thought that we would start this unit with a basic review of factoring. The first thing we want to start with is talking about the greatest common factor. And we do this all the time when we're like simplifying fractions and things like that. And we go, well, what is the biggest thing I can take out of each piece of something? So I'm just going to show you a bunch of examples and we'll see how it goes from there. So say I have 12k minus 18. When I look at this, I'm going to look at the whole piece right here. And I'm going to go, what is the largest thing I can pull out of each of them? What is the largest thing that each of them are divisible by? Now, they don't have any k's in common, so our variable we know is just going to stay the same. But I'm going to go, well, yeah, these are each divisible by 2. Is there anything bigger? Yeah, they're each divisible by 3. Is there anything bigger? We can look at it and we can go, well, they're each divisible by 6. There's several different ways to look at this. I mean, we kind of have a general idea of multiplication. If you can't figure it out, break them down. You can always look at them and go, okay, well, I've got 12, right? And I can go, well, that's 2 times 6, and 6 is 2 times 3. And that's as much as I can break that down, right? And I can look at 18, and I can go, well, that's 2 times 9, and 9 is 3 times 3. And I go, well, what do they have in common, right? Well, each of them has a 2, right? And each of them has a 3. So I have these two things in common, and 2 times 3 is 6. So I know I can pull, the biggest thing I can pull out of this is 6. Now, this is just one way to look at it. It's how I kind of see it when I'm dealing with bigger numbers. But we can look at this and go, well, I know 12 is divisible by 6, and 18 is divisible by 6. So I could just go ahead and pull the 6 out. And when I rewrite it, I'd go, well, 12 divided by 6 is 2. So I'd be left with 2k because I couldn't do anything to the k. 18 divided by 6 is just 3. And then we have factored that equation. So let's look at another example. What if I have something much bigger? Example number 2. What if I have 40 x to the, say, 8th power times y plus 64 x to the 4th times y. And I want to find the greatest common factor of these. And I'm looking at them and I'm going, well, what do they have in common? Now the numbers, fairly easy. I could still break down one of these trees, right? I could come up with a factoring tree. I could go, well, this is 2 times 20, and 20 is 2 times 10, and 10 is 2 times 5. And I've got 64. And I can go, well, that's 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. Now, do I have to do all this work? No. I can trial and error it. I can see what they have in common. Like I automatically know that 8 goes into 40 and 8 goes into 64. But if I don't know that, this is another way I can look at it. And so when I look at this, I go down this line. I go, well, I got a 2 here. and a 2 here, and a 2 here. 2 times 2 is 4 times 2 is 8. So I've got 1, 2, 3 2's here. So I can pull an 8 out of this. Everything I have left over here, I only have a 5 left over. This I'm going to have to just kind of let go, right? These are the only things they have in common are these 3 2's. So I'm going to go, okay, well, I can factor 8 out of this as my number. Now I have to look at my x's. And this one right here has 8 x's, and this one has 4 x's. So I can pull 4 x's out of each of these, x to the 4th. They each have a y in common, so I can also factor out a y. And when I go through this now to figure out what I have left, it's going to be in that parentheses. It's just a division problem. I go, well, 40 divided by 8 is 5, right? I pulled out 8. I still have 5 left. I pulled out 4 x's, so I'm left with 4 x's right here. I pulled the y out, so I don't have any y's left. Plus 64 divided by 8, well, that's just 8. And I've pulled out the 4 x's, and I've pulled out the y. So this would be my factored solution. The greatest common factor that we have here is 8x to the 4th y. So let's do one more of this type, and then we'll move on to the next type. So example 3, we've got, say I have 3ab squared minus 5a squared b plus 8ab. When I'm looking at this, it's the same thing. I'm going to pull each piece apart. Now, I can tell you right now that 3, 5, and 8 have no common factors. And the reason I can tell you that is because 3 and 5 are prime numbers. They're only divisible by 1 and 3 or 1 and 5. So we're not going to pull anything out of the numbers as far as a greatest factor goes. But what they do each have in common is they each have at least an a value or a b value. This has 1a, this has 2 a's, and this has 1a. Because they all only have in common 1a, I can pull 1a out. I can factor out 1a. Now I'm going to look at my b's. This one has 2 b's, this one has 1 b, this one has 1 b. I have to take the least common one, right? The only thing they have in common is that they all have at least 1 b, so I can factor out a b. So that's going to leave me with, we left our 3 untouched, right? There was nothing we could pull out of it. We pulled out an A, and we pulled out a B. I only had 1 A here, so I don't have any A to put in. I pulled out a B here, but I have 1 left. Minus 5. Well, I pulled 1 A out, and I had 2, so I'm going to be left with 1. I pulled out the only B that I had, so I'll just be left with the minus 5A. Plus 8, we can change the 8. And we factored out a single A and a single B, so there are no variables left on that piece. And this would be our factored piece, right? The greatest common factor of the two of those of that problem is A, B, right? They each had an A and a B in common. So when you're factoring, always look for greatest common factor first. Let's put that there. When factoring, always look for the GCF. GCF is greatest common factor first. when we're doing trinomials, we went through a whole thing in Algebra 1 where when trinomials are a little easier to factor is when they had a lead coefficient of 1, right? What does that look like? Let's see. Let's change colors here so we can see we're under a different thing. We're dealing with trinomials now. So a trinomial is a polynomial with 3 parts. And you've seen it before in Algebra 1, and it's usually you have an ax squared plus bx plus c. Could be minus c, could be minus bx, but we're going to start with where a is equal to 1. And this is where we'll start and leave off for this lesson. And we'll go into when they're not, a is not equal to 1 in our next lesson. When we have a trinomial of this type, there's a process that we'll follow. And I think the easiest way to follow that process is to use an example. Several, probably. So if I have x squared plus 14x plus 45, and I want to find the factors of this, the way I look at it is that I'm going to take c, right? Here is our c, our n term is c. All right, notice our a is 1. There's nothing in front of the x, so our a term is 1. And the idea is to take the factors of c that add to b. What does that mean? Well, it means my c here is 45, right? And my b is 14, right? So I want to find all the factors of 45. Everything here is positive. I have a plus here and a plus here. So what I know that means is that when I go to factor this, I'm going to have x plus something and x plus something else. Because everything here is positive, I'm not going to have any negatives, right? So when I'm looking at these factors, I'm going to go, okay, well, what are my factors of 45? The first thing I can tell you is that 5 goes into it, right? So I have 1 times 45. 2 doesn't go into it. Does 3 go into it? Yes. I know 3 goes into it because 4 plus 5 is 9, and 9 is divisible by 3. So I'm going to have 3 times 1, 5. 3 times 15. Does 4 go into it? No. 5 clearly goes into it because it ends in 5. So we've got 5 times 9. And I'm looking at these factors and I'm going, I can keep listing factors clearly, but we don't have to because I am looking for factors that add up to 14. And I know that if I add 5 and 9, I'm going to get 14. And so I know that the factors of this are 5 and 9. And it's really easy when we're dealing with all positive integers in our example, right? And we get that perfect match. Will we always be able to use this factoring method? No, we won't. There'll be times when it's just too difficult to do it this way and we'll wind up having to use the quadratic formula. We're going to build our way up to that. In our next example, we're going to be dealing with a negative number. So if I have x squared minus 15x plus 26, everything isn't going to be positive, right? I'm going to have some kind of a negative in here to reach that positive. Now, everything's 1, 1, so I know that my main factors are x. But what I know when I have a negative b term is that I'm going to have a negative here and a negative here. The reason that I know that is because to get my c term to be positive, I am multiplying this times this, right? We've been there before with Algebra 1. I'll re-explain that as we get going. But the main thing you need to know is that the only way I can have a positive n term is if both factors are either positive or both factors are either negative, right? Because a negative times a negative equals a positive. And a positive times a positive equals a positive. But a negative times a positive is negative. And since we have that middle term is negative, we know we need both of these factors to be negative. And I'll make a little chart for you on that as we go. So I'm going to follow the same steps, though. I'm going to take my factors of my c term. I'm going to take 26 right here. And I'm going to find out what are all my factors of 26 that are going to add up to negative 15. So we know all of our factors are negative. So I have negative 2 times negative 13. I have 3 doesn't go. 4 doesn't go. 5 doesn't go. 6 doesn't go. I believe these are my only 2. But notice if I add up, I mean, clearly I also have negative 1 and negative 26. But if I add negative 2 and negative 13, I get negative 15, right? Negative 15 is the goal. And negative 2 plus negative 13 equals negative 15. So I can just plug these numbers in right here. Do I know if I'm right? There's always a way to find out if you're right because you can multiply out these factors and see if you get the same equation. You can always tell if you're right. I could go x times x equals x squared. And then I can go x times negative 13 equals negative 13x. And I go negative 2 times x equals negative 2x. And negative 2 times negative 13 equals positive 26. And when I combine my like terms, I wind up with x squared minus 15x, minus 13 minus 2 is minus 15, plus 26. So we get back to our original equation. You can always tell if you're right. We'll get into the why we're doing all of this factoring in a little bit, probably actually in the next lesson. But this should give you a general understanding of the factoring. None of this is new material. I just know that it's been a while since you looked at it. So let's look at another example of what happens when our c term is negative. What if I have c squared? Let's change that variable. I don't want to use that variable because we've been using a, b, and c. What happens when we have x squared plus 2x minus 48? Well, now I have a negative n term, and the only way to get a negative end term, right, our c term, would be to have one positive and one negative factor. Because think about this. If I add if I multiply 2 negative factors together, I'm going to get a positive. If I multiply 2 positive factors together, I'm going to get a positive. The only way for me to end up with a C value that's negative would be to have one x plus something factor and one x minus something factor. It's the only way that'll work, because when I multiply these two things together, I need to have a negative. And the only way I can do that is if I have a positive and a negative. So the process is still the same. I'm looking at what are my factors of negative 48. I have another little trick in this, in that I know by whatever the sign here is, which factor will be bigger, my positive or my negative. This is plus, my positive factor is going to be the bigger one. If it's negative, my smaller factor is going to be the negative. I mean, my larger factor is going to be the negative. So I'm going to look at this and I'm going to go, okay, well, this is positive. So I'm going to look at, I have negative 1 times 48. I have negative 2 times 24. I have negative 3 times, how many times is 3 going to 48? 1. 8, 16. Negative 4 times 1, 2. And I'm looking at these and I'm going, have we gotten any that equal 2 yet when I put them together? And I don't see it, so I've got to keep going. What else we got? We got negative 6 times 8. Well, that one's going to give me 2. If I go minus 6 plus 8, I get positive 2. So I know these are my factors. My 8 is the positive. My 6 is the negative. So this is how I really like to look at these terms when we're factoring them out. I think of it in terms of, if I have ax squared plus or minus, well, plus bx plus c, I'm going to get an x plus something times an x plus something. If I have ax squared minus a bx plus c, I'm going to wind up with x minus something times x minus something else. If I have, let's put where a equals 1, so that can change if we have a bigger a. If I have ax squared plus bx minus c, I'm going to have x minus something, x plus something. If it's plus, this will be the bigger factor, bigger, right? This will be the smaller factor. If I have ax squared minus bx minus c, we'll still have an x minus something times an x plus something. But because our b factor is negative, this will be the bigger factor, and this will be the smaller. So I hope you take a shot at that. You're going to have to, because in the Edpuzzle, there's going to be one problem at least for you to solve, maybe 2. But give it a shot. This is not new material. The next time we'll go over how to do trinomials when a is not equal to 0, when it's greater than 0. But that is it for this lesson. Good luck, and make sure you let me know if you have any questions. I'll be happy to help.